So, very good morning, students. Welcome to IIT and NEET Foundation Program, or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the participant branches so far for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8, our ongoing chapter, heat, which is the last chapter of our material. And today we are entering into the session number 5, probably the 6th. Session number 6. That is almost the last session of the conceptual part. So remaining, when we meet next classes, we are going to revise the syllabus for our grand test. But before that, let me remind you that we have the test number 8 on coming Monday, that is on 24th, right? Test number 8. And finally, we have the test number 9, which is considered as a grand test, which covers all the 8 topics, all the 8 chapters, which is on 31st March. So we are going to complete the syllabus by this month end and remain all the 8 chapters, what we are coming in 8 examinations. If you go through all the question papers and all the worksheets given for you for the IIT month, you can appear for the grand test successfully, right? So before that, we'll continue where we left in the last class. Before going for that, let us recall what we learned in the earlier classes about the heat, right? So these are the things what we learned in earlier classes. These are the topics what we learned in the last 5 sessions. So we started with what is heat, what is temperature, how these two are related, and we have seen the difference between them also, right? Then we know how heat is measured in calories or joule. The same way, temperature is measured in Kelvin or Celsius, and this is measured by an instrument called thermometers. So there are various types of thermometers, various scales of thermometers we have seen, and we have seen the relation between them also, how to convert one value of scale into another value by using the relation. Then we enter into the second part, that is thermal expansion of solids and liquids, right? So whenever solid or liquid, of course, gases will come across in higher classes. Whenever either solid or liquid or heated, they expand. Solids expands in 3 ways, whereas liquid expands only 1 way. Solids will expand lengthwise, area-wise, volume-wise, because they have some geometrical shape. Whereas liquids does not have the shape. They always occupy the shape of the container. They undergo only one kind of expansion, that is volume expansion. It's also called as cubical expansion. So this is what we learned. So today what we are going to learn is transmission of heat. How heat transmits. For example, take when you are doing cooking or when you are boiling the water, suppose spoon is placed under the boiling water. When you are holding at the other end of the spoon, you can feel heat after some time. Why? Because heat transfers from one end of the spoon to another end. Take one iron rod and heat it on the flame. Initially, you can hold the iron rod easily, but afterwards you have to leave. That is the reason all the bowls or spoons are placed with the insulating plastic material or rubber, so that you can hold easily, heat won't transfer. Got it? So that's we are discussing. What are the different ways of transmission of heat? How heat transfers in solids, how heat transfers in liquids, how heat transfers in gases, how heat transfers in the vacuum. Okay, there are various methods which are also called as modes of transmission of heat. So today's topic we are going to discuss about what are the 3 modes of transmission with examples. So based on that, we'll show some videos also to explain the different ways or methods of transmission of heat. Okay. So these are, we discussed about the relationship, and we discussed about what are the expansion of solids, liquids, alpha, beta, gamma, everything we discussed in the earlier classes. Now some additional topic after knowing about all the heats, specific heat and all. So before going for the solid examples, we should know about what are the transmission of heat and what are the types, right? Transmission of heat. So what is transmission? Moving from one place to another. How heat transfers? Transfer of heat. We can note down transfer of heat from one end to another. One end to another is called transmission of heat. Right? Transfer of heat. You can note the first point. Synopsis for today. Transmission of heat is nothing but transfer of heat from one end to another end. Either it may be solid, liquid, or gas, no issue. Such a transfer of heat is called transmission of heat. What you can call transmission of heat. So what way heat will transmit? So there are 3 modes are there. So point number 2 you can note down. 3 modes of transmission of heat. 3 modes. Modes are nothing but methods. 3 modes of heat transfers. Heat transfer. So heat will transfer by 3 methods. Right? The first one is conduction. What is that? Conduction. You can note down all the points. That is point number, make it as point number 3 for this, 4 for this, and 5 for this with examples. So what is the first method of transfer? It is a process of transmission in solids without the actual movement of the particles. So when you are hitting any solid, for example, I told, when you are hitting iron rod on flame. So in iron rod, there won't be any movement of the particles. The particles never move because they are tightly packed. But still, heat transfer from one end to another end. Right? Suppose say this is the iron rod, A, B. We are hitting a B end with the flame. We are holding here. So what happens? It will come from here to here, and after some time, we'll feel heat and we'll leave the rod. But there is no movement of particles here. Like that, in every solid, without actual movement of the particle, heat transfers. Such method is called conduction. So when a metal rod is heated at one end, after some time, other end also becomes hot. That is example for the conduction. Note it as a point number 3, or you can second point only, you can write 1, 2, 3 again. It is the process of transmission of heat in solids. Conduction takes place only in solids without actual movement of particles. Even though you keep on heating, without movement of the particles, heat will comes from one end to another end. That is one method, one mode. So what is the second mode? Convection. It is a process transmission in the fluids. Fluid is nothing but both liquids and gases. This method takes place in gases with actual movement of the particles. Suppose when you are heating a water you are heating, observe carefully. After going home, take some water and place it on gas stove. Switch on the gas stove. Observe carefully from top. What happens when your water is heated? First water particles at the bottom will start heating. Heat will directly touches the bottom particles. Then they start heating and they come to surface, upper surface. And because they become light when you are heating, so light particles come to surface and heavy particles go down. Like that, totally due to the movement of the particles. Particles moves and collide with other particles. Because of that, the entire water will become and start boiling. So when you are heating either water or a gas, what happens here? Because their particles are apart from each other in liquids and gases, they starts moving and they'll transmit the heat from bottom to top. Bottom to top. Such method of transmission of heat or transfer of heat with actual movement of the particles. See the difference. First one is without actual movement. This is with actual movement. Right? With actual movement of the particle is called convection, which takes place in both liquids and gases. In solids, conduction takes place. In liquids and gases, convection takes place. Example C, smoke carries heat energy from flame to the flame by convection. Right? Smoke. So when you heat near the smoke, fire, at certain distance you can feel heat near. How it is possible? It carries through air. And you can feel the hotness. Third way is you can see radiation. Very important. So you may be thinking, sir, solids are over, liquids are over, gases are over. What else this is? Even through vacuum also. Radiation takes place. See, the process of transmission of is without any medium in the form of electromagnetic waves. See, our sunlight is passing through the vacuum and reaching the earth because of the radiation only. So, radiation does not require any medium. So, heat can pass through radiation also. Heat from sun reaches the earth by radiation. So, these are the three important processes or modes or methods of transmission of heat. So, heat not only makes the solids, liquids, and gases to expand, it also transmits from one place to another place by the three modes or three methods. The first one is conduction, which takes place in solids without actual movement of the particle. Second one is convection, which takes place in both liquids and gases with actual movement of the particles. Whereas the third one is the radiation, which takes place in a without medium also, even takes place in the vacuum in the form of electromagnetic radiations. Clear? These are the three methods of transmission. So before closing the session, I'll show you one example in video also for the free can see here. So all the three processes you can see in one heating vessel you can take, hold your hand there where you can find the conduction. That vessel will become heat, hand it also will feel heatness. And observe the water. That will show the convection. And heat produced bottom is the radiation. All three you can see. So here also, there are so many other examples, colorful pictures, which can show the process of conduction, convection, and radiation. Right. Right. Okay. Before that, let me show you one video. One or two videos are there to explain about the transmission of heat processes. All the three modes you can see here.
Friends, today we will learn the different modes of heat transfer. So let's start. Let's first learn what is heat. Heat is defined as the transfer of energy between two systems, and this energy transfers by means of particles bouncing into each other. So, we can say it is the transfer of heat energy from one object to the other object by means of the kinetic energy of particles bouncing into each other. When you bring two objects of different temperatures together, heat energy transfers from the hotter to the cooler object until the temperature of both objects becomes the same. Heat always transfers from hot to cold. Now let's learn the distinction between heat and temperature.
The basics.
Heat refers to the transfer of energy between systems or bodies, whereas temperature is determined by the energy contained within a singular system or body. In other words, heat is energy, while temperature is a measure of that energy. Adding heat to any body increases its temperature, while removing heat from any body lowers its temperature. Now let's learn why heat always travels from the hotter object to the cooler object. We know everything around us is matter, and matter is made up of particles, and particles have more energy at higher temperatures. So particles of hotter objects collide with slower moving particles of adjacent materials with cooler temperatures, and in this way they transfer some of their energy to the slower moving particles, and the process continues until all the particles are moving at the same rate. This is the process of heat transfer from a hotter region to a colder region. Now let's learn the units of heat. The SI unit of heat is joule. Heat is frequently also measured in the calorie, which is defined as the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Heat transfer occurs in 3 modes, which are known as the 3 modes of heat transfer: conduction, convection, and radiation. Now let's learn all 3 of them one by one. Conduction. Conduction takes place at a microscopic level. In conduction, heat transfer takes place due to a temperature difference in a body or between bodies in thermal contact without the mixing of their mass. Atoms or molecules at higher temperatures have high levels of energy. Through vibration, this energy is passed on to neighboring atoms and molecules. Or we can say vibrating atoms and molecules transfer a part of their energy to neighboring molecules and atoms.
Transferring energy,
this
not
kind
particles.
of heat transfer can take place between 2 or more substances or throughout a substance. Now let's have a look at some examples of conducting heat through conduction. When a car is turned on, the engine becomes hot, and the hood becomes warm because the heat is conducted from the engine to the hood. The cup, which is carrying hot coffee or hot tea, becomes hot, and this is due to conducting heat. If we hold an ice cube in our hand, it melts because the heat is being conducted from our hand to the ice cube. Hot food turns the plate hot. This is also conducting of heat. Placing a pan on the burner or stove makes the pan or the pot hot due to conducting of heat. Now let's learn what is convection. Convection is the mode of heat transfer in which fluids are moved in order to transfer heat. Now let's understand with the help of an example. Boiling water is an example of heat transfer through convection. First of all, a hot surface or flames heat up the pot. Heat transfers from the bottom layer of the pot to the bottom layer of the water. The warmer water moves upwards, and the cooler water moves downwards. And this cycle continues this way. Heated water is constantly replaced by cooler water in a circular manner. This way, a transfer of heat is known as convection. So here is the actual movement of heated atoms and molecules. Whereas in conduction, the heat is transferred through vibration. Atoms or molecules do not leave their original position. Now let's have some examples of heating through convection. Radiator. The radiator puts warm air out at the top and draws in cooler air at the bottom. Steam coming from a hot cup of coffee is an example of heat transfer through convection, as the steam is transferring heat from the coffee to the surrounding air through convection. Melting of ice is also an example of heat transfer through convection, as heat transfers from the surrounding air to the ice through convection. Hot air balloons are also examples of heat transfer through convection, as a heater inside the balloon heats the air and so the air moves upwards. This causes the balloon to rise because the hot air gets trapped inside. And when the pilot wants to descend or to come downward, he releases some of the hot air, and cool air takes its place, which causes the balloon to come downwards. This was about convection. Let's repeat. Convection is the mode of heat transfer in which atoms or molecules actually move to transfer the heat. And in the case of conduction, there is no movement of molecules from one place to the other. Molecules only vibrate to transfer energy to the next molecule. Now let's learn about the third mode of heat transfer, which is called
Radiation.
radiation. In this mode of heating, heat is transferred in the form of radiant energy, or wave motion from one body to another body, and no medium is required for this mode of heating, or heat is transferred through a transparent medium. The property of radiation is different from convection and conduction, as both convection and conduction require some medium for the heat to travel from the hotter region to the colder region. In the case of radiation, random movements of atoms and molecules in heated substances result in emission of electromagnetic waves that carry heat. So the heat or warmth that you feel while sitting near any hot object is due to the radiation of heat from that hot object. For example, sitting near a fireplace, you feel warm due to the radiation of heat from the fire. Heat is not only radiated from hot objects. Every object above 0 degrees Kelvin or negative 273 degrees Celsius is radiating heat all the time. Yes, every object. Let's have an example. This is a hot cup of coffee. Will it stay hot forever? No, it will achieve room temperature in some time. Why? Let's learn. All the objects that have a temperature above 0 degrees Kelvin radiate heat and also absorb heat all the time. When temperature of the object is higher than its surroundings, then it radiates more heat than the heat that it is absorbing. And as a result, its temperature keeps on decreasing until it becomes equal to the temperature of its surroundings. And then it radiates and absorbs the same amount of heat. And when the temperature of an object is lower than its surroundings, for example, a chilled glass of water, then it absorbs more heat than the heat that it radiates, and as a result, its temperature keeps on increasing until its temperature becomes equal to the temperature of its surroundings, and in that case, it radiates and absorbs the same amount of heat. So, in a nutshell, if you place a hot cup of coffee and a chilled glass of water on the same
important
table,
you can see here, hot coffee, cold water kept on same table, right? See, observe, coffee become cold and the water become hot.
after some time you can check that both will have the same temperature. It is all due to the fact that every object radiates heat and absorbs heat until its temperature becomes equal to its surroundings. Now let's learn more examples of radiation of heat. All life forms on Earth need energy from the sun, which reaches Earth through radiation. Yes, heat energy travels from the sun to the Earth through radiation. Sunlight reaches us and no medium is required by radiation to reach the Earth. So radiation can travel even in a vacuum. So we learned 3 modes of heat transfer.
Right.
Convection, conduction, and radiation.
Okay. One more small video I'll show you, which also gives some more information about the...
And takes place at a microscopic level. In conduction, heat transfer takes place due to a temperature difference in a body or between bodies in thermal contact without the mixing of their mass. So atoms or molecules at higher temperatures have high levels of energy. Through vibration, this energy is passed on to neighboring atoms and molecules. Or we can say vibrating atoms and molecules transfer a part of their energy to neighboring molecules and atoms. This kind of heat transfer can take place between 2 or more substances or throughout a substance. Now let's have a look at some examples of conducting heat through conduction. When a car is turned on, the engine becomes hot and the hood becomes warm because the heat is conducted from the engine to the hood. The cup, which is carrying hot coffee or hot tea, becomes hot, and this is due to conducting heat. If we hold an ice cube in our hand, it melts because the heat is being conducted from our hand to the ice cube. Hot food turns a plate hot. This is also conducting of heat. Placing a pan on the burner or stove makes the pan or the pot hot due to conducting of heat. Now let's learn what is convection. Convection is the mode of heat transfer in which fluids are moved in order to transfer heat. Now let's understand with the help of an example. Boiling water is an example of heat transfer through convection. First of all, a hot surface or flames heat up the pot. Heat transfers from the bottom layer of the pot to the bottom layer of the water. The warmer water moves upwards, and the cooler water moves downwards. And this cycle continues this way. Heated water is constantly replaced by cooler water in a circular manner. This way, a transfer of heat is known as convection. So here is the actual movement of heated atoms and molecules. Whereas in conduction, the heat is transferred through vibration. Atoms or molecules do not leave their original position. Now let's have some examples of heating through convection. Radiator. The radiator puts warm air out at the top and draws in cooler air at the bottom. Steam coming from a hot cup of coffee is an example of heat transfer through convection, as the steam is transferring heat from the coffee to the surrounding air through convection. Melting of ice is also an example of heat transfer through convection, as heat transfers from the surrounding air to the ice through convection. Hot air balloons are also examples of heat transfer through convection, as a heater inside the balloon heats the air and so the air moves upwards. This causes the balloon to rise because the hot air gets trapped inside.
See, this is one of the best examples.
And when the pilot wants to descend or to come downward, he releases some of the hot air, and cool air takes its place, which causes the balloon to come downwards. This was about convection. Let's repeat. Convection is the mode of heat transfer in which atoms or molecules actually move to transfer the heat. And in the case of conduction, there is no movement of molecules from one place to the other. Molecules only vibrate to transfer energy to the next molecule. Thank you so much for watching.
So these are the all the three methods clearly explained in both the videos with many examples. So many examples are given to know about this, right? So with this, we have finished the chapter explanation part. So what we learned is about what is heat. So many things we learned. Heat, temperature, difference between heat and temperature. Then we enter into the part called calorimeter. Right. After calorimeter, we define the specific heat. What is latent heat of vaporization, latent heat of fusion. At what constant temperature, how the heat, one state of matter convert into another. Then we come to the expansion of heat. That is, when you are heating any solid or liquid or gas, they expand. Solids will expand in three ways: linear expansion, areal expansion, and cubical. Whereas liquids and gas expand only one way, that is volume. And finally, we discussed about what is the transmission of heat. Heat will transmit from one place to another place, always from hot body to cold body. In the form of, in solids, it takes in conduction, in liquids and gases in radiation, and of course, convection. Radiation can take place even without any medium, right? So with this, our conceptual explanation is completed. If time permits, we'll go for the worksheet. We'll work on the worksheets given. In meantime, you can practice your worksheets for the Monday examination, right? So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.